So I'm covering like the user-facing upstream changes for non-x86. So many of you guys work in this field, so you contribute to this daily. And I personally know many of you who have like helped us achieve where we are, help us to get to where we are today in terms of having U-boot be user-friendly as a like a BIOS as a bootloader, rather than just something that transitions a system directly to Linux. So in terms of U-boot, some changes recently is boot STD. So this change came after what is it? Device manager, so DM subsystem, and it allows like faster and more streamlined enumeration of boot devices, right? And then it also cleaned up a lot of reliance on boot scripts that were littering the environment variables. So every time you saved your environment in U-boot, you saved like 8K block like chunk of data. So this removed all of the boot scripts, and then now you have a very clean environment in which you can have more flexibility to do a lot of things. And then the second one is binman, which is the sort of the compactor. It composes all of the little components like ATF and SPL, TPL into the final binary that you dump onto disk, and any associated signing that goes into that process. So that's a huge change as well, as compared to previous like random scripts for every single platform that did X, Y, and Z. So these are just like organizational changes. And then device support. So USB and keyboard support were not very robust back in 2018 when we first sort of embraced U-boot as a bootloader. And now like both the keyboard and USB device enumeration is much more stable. And then you had Linaro doing the System Ready IR initiative, which basically like, converted U-boot from a basic bootloader into like a full-blown operating system for better and worse. So you now have like standardized PC-like UEFI booting on multiple architectures. And then you also have the DT pass-through system where the DT is sent into Linux via like the control FDT is sent into Linux so that you can have one DT across both U-boot and Linux. So also enumerated UEFI variable handling for better and for worse, and then also they introduced the lightweight IP, which is you can have like a full IP stack in U-boot to do wget, which is for better or worse, a big change. And then now we've gotten to the point where with a little work, most ARM devices can boot standard distributions off distribution, but it does take a lot of coordination work between syncing the DTs, which is a lot of people are, like a lot of architectures are doing. And then also that's same for RISC-V. And on the Linux side, like in the last 5 years, the FS performance increases have been like dramatic. So you had like BTRFS, XFS, and all those file systems adopting IO Uring and then doing cal with async writes and discards. And then another innovation is Linux multimedia, which is like has skipped leaps and bounds and in some ways surpassed like previous APIs. So before you would have blobs for the GPU and the 2D, 3D, whatever component, and the codecs. And now we have stateless and stateful decoding in V4L2. Panfrost and Lima and other Mesa modules, drivers, got rid of the blobs on the GPU side. There's been dramatic improvements on the display DRM side for bandwidth saving, so ARM frame buffer compression and other means, as well as more format support. So Linux or embedded devices have display pipelines as diverse as anything. So Neil will give a talk later on that and the challenges associated with that. Live camera work, Lauren Pinchard, who's been doing a lot of the cleanup for the camera area that has all long been a black box. So now it's less of a black box, and then there's still tons of work to be done there. And then the accelerator pipelines that were introduced, I think, 2 years ago at LPC, and then for compute-only devices, so the DSP offloadings to do neural network computation and other types of computation. And then the presentation by Pidge on container and virtualization. So that also has skipped leaps and bounds by the introduction of systemd and namespaces. So so that's my bit on the changes, like an overview. And then organizing an event like this is very difficult, and it takes a lot of resources. So I like to thank the sponsor, Baylibre, for bringing their entire crew from Nice up to Paris, and then helping with the desk. Poor Patrick's like doing the front desk by himself, you know. And then Erwin for continuing to help, and you for all the AV gear. This year is like the first year where I think the post-watch value will be really good because the audio and the video is just so much better than what we were able to have previously on previous conferences. And then so the boards, a shipment got delayed at custom, but it should arrive this morning. So if you don't have one, grab one. It's a culmination of about 5 years of work. So I started looking at all the U-boot components probably in 2017, and then slowly bits and bits were cleaned up and organized, and then now we have something where we are approaching close to x86 style BIOSes using completely open source software. So, you know, Richard Stallman fans rejoice, yeah. And the boards are pretty powerful, so they actually have a lot of the subsystems and drivers that are covered by talks later today. So it's a good intro for, like, if you want to play with the stuff that people have been working on. And special thanks to the Baylibre team and then Neil Armstrong for their huge contributions, both to helping us make this possible, because we didn't have anybody to go to try to do something like this. And also the community is just, like I said, it's not just us, it's 99% of the work is everybody else. So, and also individual contributors.
Just to be clear, is this not, yeah. The one on the left, the Alta is the one that we already had. The one on the right is the one stuck in customs. So if the one on the right is the one you want, you should be able to get it this afternoon if the shipment comes in on time.
Yeah, so they all have MPUs. So these are pretty featureful boards. Play with it because they cover a lot of relevant topics in embedded systems. And then, so just a note, the firmware is, we have on GitHub a firmware builder, like a builder that does the ATF signing, U-boot, and all that fun stuff in one repository. It's called Libre Tech Builder Simple. And then you can just basically say build and then the target, which is the board name, and it will build all of it. But the problem is we enable the NPU based on Tamu's work, and that's bringing up etnaviv. Etnaviv thinks, Linux user space thinks that's a graphical device. So it'll crap out when it tries to launch X11 or Wayland. So we may provide an update just to disable that for now, and then have, we have something called the LibreTech wiring tool, which enables dynamic overlays. So it's kind of like deferred probing, but you can also merge it into the core device tree to enable it full time. So, and then we also have tools for GPIO mapping. So those pesky pin headers, if you want to change the 22 pin, you just do LGPIO set 22 equals 1. So you don't have to figure out like different socks GPIO mapping. And then the next talk is Tamu. So I'm gonna give up the stage and let him show you what he's been working on for the last 6 months. So, oh yeah, if you have any questions for me, board, or what we've been doing for the last 5 years, feel free to ask.
Hi.
Hi.
I work for Linaro. I'm the lead for the team that worked on U-boot and the
Yes, I spied you last night on, I heard EBBR, and then I wanted to talk to you, but...
That's fine. just to clear up a few confusions, right? We're not trying to turn U-boot into an operating system. The reason we're pulling in LWIP and the reason we intend to pull TLS libraries as well, and all the work we did was to get proper security support, right? Because U-boot has no CVs, we don't have a well-built community around that. All the security issues are just discussed publicly on the mailing list.
Yeah.
And for sensitive features like that, we're better off looking to a project with normal CVs and normal security procedures. And it also augments the entire stack, right? We don't have HTTPS. We had to write the IPv6 from scratch. So linking to especially LWIP, which has been used for a couple of years, just made more sense.
Yeah, like to be honest, it's a ton of work, right? So having a full IP stack is a ton of work. So I've seen like all the patches to the trees over the last 4 years, and then I personally like it. I'm just like we use it on our devices. So if you boot it up, it's all like half of that that is Lenaro's eBBR work. So that's awesome. We don't use that.
There's a few more things that are coming up. There's a U-boot menu, for example, that you can lock down your board if you want, so you won't go into the U-boot console. That's geared towards productizing and securing those boards. But our intention is not to change U-boot, right? All those features, you have to buy into them. You have to enable them. They're not enabled by default. They're just there to do the entire infrastructure if you want.
We make good use of it, but like a lot of embedded people don't make good use of it. And also referring to the secure world stuff. Like we don't have the previous talk on hardware as silicon root of trust. So we've been trying to get the plumbing all the way down to open source plumbing all the way down to the like ATF layer on the stuff that we use, right? So we've been people who want to do it, as well as we're trying to locate resources and also talk with the silicon vendors that we use to push this to more open source side so that we can actually have secure platforms. And then that's something we've been working on as well for the last few years. And then as we gain in scope, we can push that forward through either sales side and technical side of these closed chip vendors. So the big ones won't give a crap, excuse my French, give anything about us. But we might have inroads into the smaller SOC manufacturers.
Hey, about this turning U-boot into a full-blown operating system, we actually recently grew support for how do you call that, coroutines maybe? So from the main shell you can register like callbacks which get called at certain points repeatedly, so you kind of have cooperative multitasking now. I mean, maybe Linaro is not trying to turn it into a full-blown OS, but it's kind of heading in that direction anyway.
Yeah, I do see people actually writing drivers in U-boot because since it's like at the most privileged stage, so you have people writing like drivers by changing registers and shells in U-boot scripts, and then it's a good tool, right? So like any tool, depending on how you use it, you always use the best tool for the job. If U-boot is the best tool, then you go right ahead. If Linux is the best tool, go right ahead. If some BSD is the right tool, yeah.
We should definitely talk after this.
Okay. Anything else? So I'm going to give it up for Tamiu, who's going to be introducing the NPU stuff, which is what I think is awesome because that's the next 10 years of computing right there.